Okay, we're going to talk about the frequency counter pattern as an approach to solving certain classes of algorithmic challenges. And we're going to take this example problem here, where we essentially want a function that will accept two arrays of integers. And the function should return true if every value in the first array, every integer in the first array, has a corresponding squared value in the second array. And the frequency must be the same. So if we have 1 here, 1 times 1 is 1, we must have a corresponding 1 in this array. We have a 2 here, 2 squared is 4, we must have a corresponding 4 in this array. We have a 3, we must have a corresponding 9 in this array. We do, so we return true in this case. This array, we have 1, we have 1, we have 2, but there's no 4. So we know that this is false. And furthermore, we know this is false right off the bat because the lengths are different. And we say that the frequency of values must be the same. And by that, we just mean, really, if there's a certain number of values in this array, there must be the same number of values in the second array because you have to manually specify. So, for example, here I have 1 and I have 1. So I need 2 1s in this array as well. I can't just have 1, 1. And this makes it actually quite a bit harder for reasons that we'll see. So anyway, we'll just go through, and I think you get the basic idea of what we're trying to do here. All of these other test cases are going to be pretty similar. This one, these are different lengths, so it's going to be false. This one is true. It just has a lot. You'll see, for example, there are 4 3s in this one. So we have 1, 2, 3. Oops, 4. We're running a little bit off there. Oops, that's okay. 4 9s in that one. So that one returns true. And this is in Dart, as you can see. And if you're familiar with JavaScript or Java, Dart is really similar, and it's one of the reasons why I used it. Also, you can go to this URL right here, and you'll be able to see this in action. And I'll post this in the description, everything below. So here we have our function. It's called same. It returns a Boolean value. It takes a list or an array of integers as the first argument, and then another list of integers as the second argument. And right away what we're going to do is say, okay, if the lengths aren't the same, then return false, because we know that they aren't the same. And then if we get to here, we're going to create a map, and the map is going to have an integer key and an integer value. And the integer key in this map is going to be our squared value, and the integer value is going to be the frequency count of that squared value. So we're going to define a variable here outside of our loop, because we don't want to generate a new variable for every iteration of the loop. We just want this one variable, and we'll reassign it. And then we're just going to say for every integer n in that first array, or that first list of integers, square the term, so n times n, just like we walked through in the example problems, and update the list. Now this is something that is a little Dart specific. It's this update method, which is really cool. We can see here that update takes an integer key and then a function, an update function, as a second parameter, which takes that that value, the current value of that key, and then an optional parameter, which is also a function called if absent, that is run if the key doesn't exist. So we can also look at that here. Basically says the same thing. So this update method takes a key, takes an update function as a second argument, and then an optional if absent argument to run if the key doesn't exist. So we're going to use all 3 in this first example, looping through this first list here, for example. So we're going to say for 1, for 2, and then for 3, run some logic. So for n, or in this case 1, square the term, and then take that squared value and check if it exists in our map. And if it does exist, take its current value and just increment it. And if it doesn't exist, just set that value to 1. So we can just run through real quick here and see what that would look like. So our map is going to be just like a JavaScript map or something. We have nothing. We start with nothing in it, and then we say, okay, int n is 1. Square it. 1 times 1 is 1, and then we have the square. So we have 1 here, and then it doesn't exist. So we're going to run this if absent function, which returns its value set at 1. So we'll do that. And now we have that in our map. And then we're going to go up, and I'm just going to copy this here so we have that right by us. So this is the function that we are pretending to run here. So then we have 2, and so for 2 we square it, we get 4. We say we have our key there, 4, and then we check if it exists. It doesn't. We run this if absent function, which sets it to 1. So then we have 4, 1 in our map. Then we run 3. We do the same thing. It's not there, so we run 3, and then we have it updated to 1. So that is what our map looks like. Let's bring our map down here and just look at what our second piece of logic does. Because if you've noticed, we have 1 iteration over 1 array. So we are already at linear time, a big O of n, because we're directly basing our time on the length of the first array. Now, you could have a quadratic solution to this, and you could say, well, for every element in here, for this one, check all of these. For this one, check all of these. For this one, check all of these. And you could do something like splice it out. So you could say, okay, for 1 times 1 is 1, find 1 in here. If 1 exists, splice it out. And go about it like that. But that would be quadratic time, because you're doing, for every n item in here, you're doing another n operations. So this keeps it linear using this map. And that's really the whole point of this frequency count pattern, is to move from quadratic to linear by just having these constant time searches. Instead of having to loop through an entire array, we just do a constant time search by using an object or a map or something like that, to just say, oh, hey, does this exist? If it does, then update it. If it doesn't, then initialize it to some value. And it's a really common pattern, and it's super useful. So what we're going to do, now that we have constructed our first map based on the values of that first array right here, this first array, we're just going to run through the second one and compare it. So for every integer in A2, here, first of all, the key must exist. So let's take 4. So we have 4. If our map contains the key 4, if our map does not contain the key 4, then return false, because right away we know that they're not equivalent. So if it does exist, then we're going to decrement the key. So m.update, we're running our update function again, which takes the key, which in this case is 4. This case is 4. And then we are going to do our update function, which just decrements it. So we find 4 in the map, we decrement it, subtract 1, so now that we have 0, and then we return our updated value. So we have 0 here. And then we're just going to check that this value is greater than 1, or is not less than 0. So if it is less than 0, we need to return false, because it means that there wasn't an equal number of terms. So because it's only 0, that's fine. It just means that the two arrays are balanced. We won't return false. We're going to move on to the next thing, the next item in this second array, which is 1. So we're going to say if M doesn't contain that key of 1, then return false, but it does because we have it right here. And then we're going to update it. So we're going to decrement this value so that it becomes 0. And then updated value is not less than 0. So we're just going to move on to the next item, and it's 9. So then we're going to check that 9 exists. And I'm sorry, this is a mistake. That should be 9 because remember we squared the terms here. When we pushed to our array, we squared them. So when we went through 3, we would have squared 3 and pushed the squared version of 3, which is 9, onto our map. So when we run back through it, we have this value of this 9 that we check, and we do have a 9 key right there. We have one of them, and then we just decrement that just like we did all the others. And we ran through our whole map. We have a nice balanced map now. Everything's 0 because the same number of squared terms existed, and then we just return true. And that's pretty much it. That holds for all of these cases. We can confirm that by just uncommenting these and running it. You don't have to know too much about this assert function. It's really simple. It just takes 2 booleans, and if they're equal, it says pass. If not, it says fail. And we're just saying, this should return a boolean, true if they're the same, and because this meets those criteria, this should be true. So we can just run that here, and we see that all our tests pass. And that's it. This example, we would have 1, 2, 3, 4. We'd have 4 9s. We'd have a value or a key of 9 with a value of 4 in it, and we would decrement all the way to 0. Those conditions are going to hold for multiple values as well. And that's the frequency count pattern. Let me know if you have any questions in the comments, and I will try to respond. Comments, criticisms, anything like that, let me know.